Hi, everyone. Thank you for joining us for today's webinar on an integrated solution for test data generation and data validation. My name is Liz Levine, and I'm the Marketing Manager for QuerySurge. I'll be your webinar moderator today. Eric Smythe, QuerySurge's Director of Alliances, will be kicking off the webinar with a presentation of QuerySurge, the smart data testing solution, and how GenRocket's enterprise test data automation works. He'll be joined by Garth Rose, CEO of GenRocket in the presentation, and Heisel Taylor, founder, CTO, and chief architect of GenRocket will be answering questions for you with him. This will be followed by a demo of the integration of GenRocket with QuerySurge. If you have any questions during the webinar, please type them in your chat window. We will answer all your questions during a Q&A session after Eric's demo is over. Also, please use the chat to alert the host if there are any issues seeing the presentation or hearing the presenters. Thank you again for your time and participation. This session is being recorded and will be on our website so you can share with colleagues. Now I'll hand it over to Eric to kick off the presentation.
Thank you, Liz, and thank you for everyone for joining. As Liz mentioned, my name is Eric Smythe. I'm the Director of Partner Alliances on the QuerySurge team. What I'm going to do today is present a little overview of how QuerySurge and GenRocket can help you complete your data equation. As the title says, test data generation and data validation equals data success. So what we're going to look to do is present the problem that many organizations are facing with their data testing and show you how GenRocket and QuerySurge can help with a solution to tackle those challenges that you may be facing. So with that, let's get started. First, let's take an introduction to the problem. Right? We know that executives are making critical business decisions based off of BI and analytic reports. And of course, the assumption is that the underlying data behind that report is accurate. But we know that's not always the case. Bad data can be introduced into the system, and that can cause problems. So for example, your architecture may look something like this, where you have multiple different data sources that are being ETL'd into some type of data warehouse. That could be then transferred into multiple data marts that are feeding into those BI reports. Simultaneously, there may be data lake projects going on that are integrating into your warehouse. You may be executing data migration projects, and there may be ERP systems that are feeding information as well into the architecture. So the point is that anytime data is moving between one piece of architecture to another, or one system to the other, there's a possibility of some bad data being introduced. And of course, the challenge is, how do you know where the bad data was introduced? How can you detect those issues? And how can you appropriately apply fixes to resolve those types of problems? So what are our goals when trying to overcome these challenges? Well, the first is we want to be able to validate the critical business rules and transformation logic being applied to the data. So as data is moving from one system to the other, where is that data going? Is any transformation happening to that data? And how can we go about testing that to make sure that that's accurate? We also need the ability to test large volumes of data in a period of time that's not going to delay the release schedule. Organizations now are doing daily, even hourly ETL loads that can be executing millions, if not tens of millions, hundreds of millions of records. So how do we have the ability to test those records in the amount of time necessary to align with our schedules? Another thing we'll need to be able to do is pinpoint exactly where the defect is introduced. Just being able to run a BI report and notice that something's incorrect doesn't give us much information about where that defect was originated. Being able to locate and go back and try to find that information can be very difficult. So we want to be able to pinpoint when a defect gets introduced into the architecture, exactly where that is. And we want to be able to do this in an automated fashion. Whatever testing we want to do, we want to be able to align this into our continuous integration or our continuous delivery pipeline. So in order to accomplish those goals, there are a couple major issues that we have to deal with. The first being, how do I generate the data needed to conduct the tests that need to be executed? Organizations struggle with this for a wide variety of different reasons. One could be that this is a new project and they simply don't have the data necessary to conduct the test that they want to run. Or they have some data that they need, but it's not complete enough. It doesn't check all the edge conditions. It doesn't have all the associations that need to be made in order to be tested. Or they may have a good set of data, but it might be production data, and that data can't be used in the test environment for security reasons. So these are all challenges that we need to overcome if we're going to be able to use data to be able to put through this architecture to execute our tests. Another big problem is, how do I execute these tests in an accurate and efficient way that aligns with my testing cycle? What we see a lot of organizations doing now is sampling, just testing a few records here or there, trying to do eyeball checks. Some organizations are doing minus queries that put a lot of stress on the data architecture that they're using. And it's not a great and efficient way to conduct these tests. And as the data grows and you're getting more and more data, it becomes more and more difficult to overcome these challenges. So if we're going to set up an ideal testing strategy, what are some of the things that we need to be able to accomplish in order to do this? One, we need to be able to accurately and rapidly generate all the data needed for the scenarios that need to be tested. So we can't go around trying to gather information from all these different systems and trying to put the data in a way that we can use to run tests. That can be very time consuming. And we're looking to cut that time and get all the data we need in order to do our testing. Also, we want to be able to mask the data to ensure data security. Again, many organizations have restrictions on what data is available for the testing teams. So how do we create the data necessary to do the test and make sure that the data is masked in a way where we're not breaking any of those security protocols? We want to be able to validate large amounts of data quickly. If you have nightly or hourly ETL loads, you can't have the entire process backed up because testing hasn't been completed yet. We need to be able to run these tests in a quick manner in order to align with our delivery cycles. We need to be able to validate difficult transformation rules between the various source and target systems being tested. So as data is moving and being manipulated, we need to be able to ensure that those manipulations that are being done by the ETL tools are being done correctly. We want to be able to integrate your build pipeline to achieve continuous testing. So anytime any type of process is running, we want to be able to test it right away, be able to validate it, and if there are issues, notify the people that need to be notified so that they're able to correct them. In addition, we want to have historical results and provide analytics around all of our data testing that we're doing. So how can we accomplish these goals? Well, to overcome these challenges, we're going to demonstrate two products that can help you implement and accomplish that testing strategy we just went through. The first is GenRocket, which is used for test data generation. And the second is QuerySurge, which is used for data validation. What I'd like to do at this time is turn the presentation over to Garth Rose, who is the CEO of GenRocket, to explain a little bit about the GenRocket solution and how it can be used in this type of scenario. Garth?
Hi, Eric. It's wonderful to be partnering with QuerySurge, and we'd love to introduce GenRocket to the audience. And as you can see, we're an enterprise-class test data automation platform with the core capability being around data generation. And what you're seeing on the screen is really true. We've been around for over 9 years, and this is a very fast platform. It can generate data for a functional test in under 100 milliseconds, but also can generate millions or billions of rows of accurate data. It's fully secure because we're generating synthetic data. It's a very attractively priced solution, and because we work with enterprise accounts across the world in different industry verticals, a lot of versatility. And of course, high quality data, and that's something we're talking about today, isn't it, Eric? So this solution is being recommended by numerous global systems integrators, and in terms of the test data generation category, it's the only patented test data platform out there. And that patent, by the way, is for generating test data with referential integrity. I'm sure many in the audience want not only to be able to generate data, but it must be accurate, it must be valid. Next slide, please. So how does this architecture work? Eric's going to be providing a great solutions demo in a few minutes, but you'll hear some of these components that he talks about, but we want to introduce them to you now. If you understand these 5 key components, you really understand the basis of GenRocket. So there are 5 key components. You see them on the left-hand side. The first is the domain. It's a noun. It's a person, place, or thing. Equivalent to a database table, but certainly more versatile. We aren't just dealing with databases sometimes. So you might think of an organization domain or department domain and a user domain, as we're showing here, or an address domain. No limit in GenRocket on the number of domains or the complexity. What are the characteristics of a domain? We call them attributes. So that might be a name, a phone number, a social, a date of birth, a credit card, or a member ID. Those are examples. Today, we have a little bit more than that. We have about 258 generators, and we associate the generator with the attribute to generate the data. And we have, again, generators for whatever you might need. So for names, credit cards, phones, and so forth. You see those examples. And note that we also have query generators, so we can actually, from a staging server, for example, query production data and blend that with generated data. Now, the 4th component is the receiver. We now have over 60 receivers, and receivers receive that generated data and morph it into a usable format, like XML or JSON. GenRocket can talk to just about any database, SQL database, DB2, Oracle, SQL, etc. We can talk over web services, over JDBC, over REST, over SOAP. We can do fixed file formats like CSV and VSAM. We have specialty solutions for banking like Notcha. We have EDI. The point is over 60 different receivers, and we are able to add new receivers to the platform in 2 to 3 weeks and new generators in 1 to 3 days at no cost. So when we said versatility a bit earlier, it's because this platform just continually grows depending upon our customer needs. Now, everything gets pulled together in a scenario, which is an instruction set. It doesn't contain any data, but when executed, in about 100 milliseconds for a typical functional test, it generates that data very, very fast. And we have a concept of 1 scenario per domain. So that's the way we can handle referential integrity between the different domains, the different scenarios. Eric, if you could just go to the next slide. We found this next one is really useful to sort of think about how GenRocket works. So in the center of the screen there, you see the engine, the patented GenRocket engine. And that spins up in 10 to 50 milliseconds. And then it leverages a scenario. You'll see Eric doing that in his live demo. And the scenario is an instruction set. And inside that scenario might be the domain. It'll have the attributes, the number of generators, and it'll also have a receiver. And that receiver, for example, above the scenario in the middle there, you'll see you can produce it in XML or JSON. And then that data is sent, whatever the receiver says, is going to go perhaps to a functional test or a unit test, or in an ETL example, database loading. So it's complete versatility in terms of the different use cases that GenRocket's used for. And we get asked this all the time. If you look in the bottom left-hand corner, of course we work with Jenkins and CI/CD pipelines, open source tools like Selenium, and it also, of course, will pretty much any commercial testing automation tool. We even integrate GenRocket through our API with a wide variety of custom testing tools. So that gives everybody a good background or framework. Eric, I'm going to hand it back to you because I know we're going to learn more about QuerySurge and also see a live demo.
Thank you, Garth. So the next thing I'd like to touch on is what is QuerySurge? So QuerySurge is the smart testing solution for the automated validation and testing of data. We list our use cases here. We started our focus primarily around data warehouse and ETL testing. So being able to validate when you have many different sources that information is getting into the target data warehouse accurately. Right around the time when we launched in 2012 is when the whole big data concept exploded, where people were looking to use NoSQL data stores like Cloudera, Hadoop, MongoDB. So we wanted to be able to ensure that we could work with those and be able to connect to those systems as well. And QuerySurge is able to connect to big data systems and use it as any other source or target within our tests. We have a good DevOps continuous testing story where you can take these tests and kind of put it into any type of data pipeline that you may have. We're going to demonstrate this a little bit later for you. One of the use cases that's been popular recently is data migration testing. As organizations are going through their digital transformation and they're moving maybe on-premise data stores into the cloud, or maybe they're redoing their architecture, or it could be just upgrading the latest version of the vendor software, QuerySurge can be used to validate that that migration process is done quickly and efficiently. We have an interesting solution for BI report testing. We capture the data from underlying graphs within BI reports, and then we can take that data and compare it against any other data source, either other reports or graphs, the data mart that's being fed into those reports, or any other type of data source. And lastly, enterprise app ERP testing. If you have an ERP system and you have many different data feeds that are coming into that ERP system and you want to make sure they're coming in accurately, QuerySurge can be used to validate that process. So essentially how QuerySurge works is we have a concept of a test, which we call a query pair. And what the query pair does is connects to any two data points at one time when it's executed. So for instance, you'll specify a source. The source could be a traditional database, could be a mainframe, a flat file, or some type of web service. Your target system may be a data lake, a data warehouse, a BI report. And depending on where you are in the architecture, what is a source in one query pair could be a target in another query pair, because you're testing these different endpoints. And what will happen at the time of execution is QuerySurge will make a request to the source system, a request to the target system. It will retrieve that data back into a unified result set, and it will compare every single cell of every single record. And it will look for any type of data anomalies, such as maybe there were records in the source system that didn't make it into the target system. Or maybe there was some type of truncation problem where the data in the target system is not being displayed properly, or any other type of bad transformation that you can think of. And what QuerySurge will do is it'll collect all those metrics. It'll provide analytics and dashboards around all of the query pairs that have been executed. We also have automatic email triggers that will be fired off to notify users if there is a data issue that is uncovered during the QuerySurge execution. So what I'd like to do now is illustrate a little bit about the process and how both GenRocket and QuerySurge can kind of be injected into what type of testing you're doing now. So for instance, let's say we have a very simple architecture here where we have databases and flat files, and the information from these databases and flat files are coming into a target data warehouse system. So what happens now is your organization is either using some type of ETL product or maybe writing Python scripts, and they're taking the data from the source, transforming it, and loading it into your data warehouse. So of course, the problem is if you're looking to conduct tests, you may not have the data that's needed in the database to populate the data warehouse to run the tests that are necessary, or you may not have the files needed in order to check all the different scenarios that you want to have tested. So GenRocket has the ability to inject the data into your existing databases or generate the files needed for this process. And then once the data is generated, you can then use QuerySurge to collect the data from the source systems and then compare that to the target systems. So you can see the test data generation point is where the data is injected, and then the test data validation point gets done after that ETL process is executed, and we can compare the data from the source and target systems. So what I'd like to do now is showcase a particular use case. We chose the use case to break it down into a very simple example, something that we can properly explain and articulate in the presentation, but also having enough complexity where you'll see some of the transformation challenges and some of the needs that you may have in this type of scenario. But one thing to point out, even though this example may be pretty basic, all of the concepts that we're applying can be used in much more complex scenarios. It's just building upon kind of these building blocks that we're laying out. So let's take a look at this use case. So in this example, we're going to have a customer fact table that's going to exist in our data warehouse. And what we're going to look to do is test two key transformations that we want to test in this scenario. The first being in our source system, we have the countries that are associated with the customers as full names. But when that information is being transformed into our data warehouse, that's going to be transposed into a country code represented by 3 alpha characters. So one of the things we want to test is that all those codes have been loaded into our target system correctly. And the other scenario we want to test here is that we have a field in our customer fact table called VIP status. And the VIP status is what we call a derived field, meaning the value doesn't exist anywhere in the source data, but it's determined based off of some of the fields that do exist in the source information. So we have an orders table, which will have a bunch of orders placed by customers. And depending on how many orders that customer placed will determine their VIP status for the year. So you can see the breakdown here. If a customer doesn't place any orders, they're at the lowest level. If a customer placed 1 order, they're at level 1. Anywhere from 2 to 3 orders puts them at level 2, and so on and so forth until they get to over 10 orders, which puts them at the highest VIP level, level 5. So in this example, what we really want to test is we want to do combinations of customers from every different country with all the different possible VIP ordering statuses. So it could be that we don't have the data necessary to do that. Maybe we only have working in 10 countries right now, but we're looking to expand. So the data that we have doesn't give us enough of a range to conduct all the tests that we want. So in our source system, we're going to break it down into 2 tables. And again, these tables are very simplified. Obviously, in a production environment, you're going to have many more columns. What we're doing is trying to kind of limit it to make it easy to visualize and easy to cover. So what you'll see here is a customers table. The customer table has 2 columns. It has a customer ID, and it has the country of origin for that customer. And then you'll see that there's an orders table, and you'll see that orders table is going to have an order ID. And it's also going to reference the customer that placed the order. So the thing to note here is you'll notice that customer ID 1 has placed 2 orders. The customer with ID 2 has placed 1 order. And the customer with an ID of 3 hasn't placed any orders in the system yet. So what we would expect to see after the ETL job runs to take this information is to populate a customer fact table, which will have the customer IDs. Instead of the country's full name, it's going to have the country code, and it should have the accurate VIP level that's needed based on the number of orders placed. So what we're going to take a look at now is how you can use GenRocket to generate the data necessary in order to verify that ETL use case that we just walked through. So the first step is you're going to create domains in GenRocket. And in this particular example, we're going to create one for each database table. So we're going to have 3 tables here. We're going to have a customers table and the orders table that you saw in the previous example. But one of the things we're going to need is we're going to need a lookup table to do the transposition between the country name and the country code. So we also have a domain for the country as well. And if you drill into one of these domains, what you're going to see are the individual attributes. And these attributes represent the fields that are going to be populated into those source database tables. You'll see for this particular example, for the customer domain, we have 2 attributes, a customer ID and the country name. And you'll see here the customer ID is going to be auto-generated and populated sequentially, but the country is coming from a country table that is another domain that we created. So we have the integrity between the different domains within this architecture. The next thing we're going to do is we're going to create a scenario for each domain. And what the scenario is going to determine is how much data is going to be generated for those tables and what should be done with that data. Should it be put into a file? Should it be put into a database table? Where is that data going once it's been created? And lastly, then we're going to create a scenario chain. We're going to take all the scenarios that we've created, create a sequence of events, in which case they should be executed, and put that into this chain. And the chain is what GenRocket actually uses to do the execution, which will run, create the data, and populate it where it needs to go. So next, we're going to take a look at QuerySurge and how QuerySurge is going to be able to be used to validate this process. So as I mentioned earlier, QuerySurge has this concept of a query pair. The query pair consists of a source and target query. The source will be aligned to connect to the specified data tables that are going to be our source system. And the target is going to be connecting to the data store, which is going to be our data warehouse. And then what we'll do is we're going to define the queries necessary to pull the data out so that we can do a comparison of the information. Once that query pair has been created, we're going to add that to a test suite. A test suite is used to execute multiple query pairs or multiple tests in conjunction with each other. In this particular use case, we are able to validate everything we need to validate in a single query pair. So the suite is only going to have a single query pair in it. But as you could imagine, more complex scenarios, you can have many different query pairs that you need to execute to validate a particular ETL job. You would include all of those query pairs in the suite, which enables you to execute them together. And then what happens is there's a scenario that will execute. It will run one or more suites. Those suites will query both your source and target system, bring the data back, perform an analysis, and then give you information if there are any type of data issues that occurred during that process. And lastly, what we want to be able to do is once we have those pieces in place, we want to be able to put it into a build pipeline, which will be able to execute them as part of our continuous integration and continuous delivery model. So in this particular example, and this is what we're going to demonstrate for you in a moment, is we're going to use Jenkins, and we're going to create within Jenkins a build pipeline. And the first phase of that build pipeline is going to be to generate the data needed to execute the tests. And Jenkins is going to make a request to GenRocket using the execution API. GenRocket is going to generate the data needed for our testing, and it's going to inject that data into our source database. Once we now have the data needed to conduct the test, the next phase is to execute our ETL process. So Jenkins will kick off an ETL job. That ETL job will make a request to the source data, perform whatever type of transformation is needed in order to create the information that's going to go into our data warehouse. And then it will inject that data into our target system. Now, once that process has been completed, we want to make sure that the ETL job worked correctly. So we're going to make another request to run our validation tests to now verify that the ETL job did what it was supposed to do. So that is going to make a request to QuerySurge using our execution API. QuerySurge will then query both the source and target systems, bring that data back, and do an analysis to make sure that the ETL job executed correctly. It will take that status and will provide whether it was successful or not back to Jenkins. So the Jenkins build will know if we were successful in our pipeline. And we can also kick off an automatic email trigger notifying the team members if we did run into any type of issue. So hopefully that sets the context of what we're looking to accomplish and how these products can work together. So the next thing I'd like to do is to actually show you the tools work to specifically around that use case that we're working with. So the first step in that process, as we just discussed, is to generate the data. So I'm going to first log into the GenRocket application. When you first log in, you'll see your project dashboard. If you have multiple projects, you'll have all the information here for the various projects you're working on. In this particular example, I have a single project called webinar, so I'm going to drill into that. And what I want to draw your attention to is the domains. So as we discussed, we have a domain for each one of the database tables that we're looking to create. So I'm going to drill into this country domain just so you can see what's contained within it. And on the left-hand pane, you'll see we have two attributes. The first one is for the country name, and the second one is for the code, the three-letter alpha code that's being generated from that country name. You'll see at the bottom we get a little preview data of what that data is going to look like. So you can see the country names and the codes that are listed here. You'll also see the loop counter indicating that we're going to be generating here 235 countries. Now, if I drill into one of these attributes, what you'll see is some property information up top, but down below you'll see the actual generator. So what's creating these country names? So this is where the generator that Garth spoke about earlier are available. So we're calling this country list generation. And this is what's being used to populate this particular attribute. And you'll see in this particular case, we're displaying the full name. But as Garth mentioned, there's over 250 different generators that are available. So as you can imagine, over time, as customers continue to ask for more information to be used for their testing, more generators are created. And there's a pretty extensive list here that you can include in any type of listing that you may have. Just to jump very quickly to the code attribute, you'll notice that the data to show here is the 3-character alpha representation of that country. It's using the same generator, but we're just choosing what to be displayed in this case. And you'll see the little preview tab will kind of show you how that information is being displayed. So I'm going to go back to the project level. And the next thing we're going to touch are the scenarios. So again, each scenario is created around the domains, and this tells us how much data to create, and not only that, where should that data go? Oh, and one other thing I forgot to mention, which I definitely wanted to display, just to go back to the domains for a minute. There's also this relationship tab, and what this does is this shows the correlation of how the data is correlated between the different tables that we're working with. So you can see here right now I'm in the customer domain, and the information, which are the country names, are being populated from that country table, that country lookup table that we're creating. And at the same time, the customer IDs that I'm creating are also being injected into the orders table. So very important, it shows the relationship of the data between the different domains that we're working with. So now going back to the scenarios determine how much data to generate. In addition to that, where that data should go. So I'm going to go to kind of the lowest level child, which is the order scenario. I'm going to drill into that for a moment. And what you'll see is that we have 235 countries being generated. We're creating 5 customers, so 5 customer IDs for each country. And then we're placing a set number of orders, or a random number of orders for each customer. Right, so not all customers are going to place the same amount of orders, because I need to test that range of my VIP level. I need some customers to place, over 10 orders. I need some customers to not place any orders, and I need, all the ranges in between. And you'll see that that is defined by this child loop count attribute that is in my customer domain. So just to show you that real quickly, if I go to the customer domain, you'll see there's this child loop count attribute. You'll notice that there's, I don't know, it might be a little hard to see through the web session, but there's colored icons indicating this is data that's actually going to go into your source system. And then there are gray icons indicating these are hidden fields, meaning they're used to generate the data, but they're not being injected anywhere. So if I go into this child loop, what you'll see is we're just doing a random number generation, and our starting range is 0. So we may have some customers that don't place any orders. And then my end range is 12. So that's the high limit we're going to specify for this test, which is over the 10 that we need for that highest level VIP status. And you see it gives you a little preview of the number of orders that each customer, in this case, might generate. And then going back to the domain, or I should say the scenarios for a moment, one thing I did want to show you is the receiver. So this is what's happening with this data once it's being generated. So in this case, we're generating this into a SQL statement to be injected into a SQL table. And there's configurations, of course, of what table you're going to be connecting to and the different parameters needed to connect to those databases. So once you have all this defined, if we go back to our project level again, you'll see that we have a single scenario chain here. And that scenario chain is just listing the scenarios that are going to be executed in sequence. So first we're going to create the country table, then populate the country table with customer information, and then create the order scenarios. And then what you have the ability to do is to download that file. So what this is going to do is GenRocket is going to create a file, in this case called all scenario chain, that gets downloaded to my machine. And then if I have the GenRocket engine installed, I can run that file and it's going to create the data for me. And that's exactly what we're going to do. So what I'm going to do is I'm going to show you our database tables. So if you look off to the left here, we have a sales database. And we have the different tables that we just talked about, the country lookup table, the customers, and the orders. And you'll see right now, these tables are blank and don't contain any data. So what I'm going to do is I'm going to now go to that GenRocket file that was downloaded. So you'll see I have a folder called GenRocket Scenarios. That all scenario chain has a GRS extension. And I'm going to execute that file from the command prompt. You see it's a pretty basic command, GenRocket/R, and then the name of the file. And then what it's going to do is it's going to generate the data based off of those configurations that we set in the application and inject them into the database. And now if we go to these different tables, so first I'll look at the country lookup and I hit refresh, you'll see it created the country names along with the country codes. Next, if I go to the customers table, you'll see if I refresh, the customer IDs as well as the country names. And notice we generated 5 IDs for each country that we're working with. And lastly, if we take a look at the orders table, we have order IDs and then the customers that purchased that order. And one thing to note here, notice that customer 1 only purchased 2 orders. It looks like customer 2 purchased 8 orders. And you'll notice if you look down, customer 4 didn't place any orders. So it's creating the data I need in order to conduct my tests. So once the data has been created, the next step is let's go ahead and run our ETL process. So we have a very basic ETL process set up. I have a bat file, which is going to run this ETL job. And once the batch file completes, it's going to do the transformation and load that data into our target data warehouse. And you can see we've reached 100%, so that's been completed. So I have a data warehouse called corporate DW. This was the customer fact table that we were referencing in our use case. So you'll see I have a tab open here. And if I hit refresh, the ETL job now populated this data into the data warehouse. So once the ETL job is completed, the next phase is I need to test it. Is this data accurate? Does it have the information it's supposed to contained within it? And for that, we're going to take a look at QuerySurge. So when I first log into QuerySurge, you'll notice you'll see a dashboard. Each user gets their own dashboard to display metrics and content that are relevant to them, completely customizable and configurable. You can move these widgets around You can add new widgets and customize the widgets to really track information that is specific to what you need to track from a testing perspective. But what I really want to do is kind of jump into the test, specifically what we're looking to validate here, which is in our query pairs folder. So if I open up my queries pair folder, you can see a completely customizable folder. You can create as many subfolders as you need to. I have a folder here called webinar, and I have a webinar use case. So I'm going to open up that webinar use case. And what you'll see is a source query on the left and a target query on the right. The source query is connecting to a sales database, and my target query is connecting to our data warehouse. Now in a query pair, you can specify any source or any target. You can see this is a demo environment, so I have quite an extensive list here, whether I'm connecting to CSVs, AWS Redshift, big data stores like Hadoop and Hive tables, BI tools, or traditional databases, pretty much any data store that has a JDBC driver, QuerySurge is able to work with and test and validate. These are configured in the administration area. So just to toggle there for a moment, if we go to our connections, you'll see we have all the connections defined. And if I go to the specific sales connection that we're working with, you'll see that this is connecting to an Oracle database. It has the port, the service name, the login, and all that stuff is saved in the connection. So anytime I need to use that information that's in that database for a test, I can simply select it from the dropdown within QuerySurge. And you'll see the query on the target side is pretty basic. We're just asking for those three fields from our data warehouse. On the source side, we're putting in the logic to test that transformation. So we're joining a couple different tables, including the country lookup to get the alpha code. Also, you'll see a case statement that's used to handle the VIP level status based on how many orders that a particular customer created. So when I'm ready to run this test, I can go to the design time run and hit execution. And what QuerySurge is doing now is it's running a query to the source system. It's running a query to the target system. It's bringing that data back, and then it's going to perform an analysis to see, did the ETL job work correctly? And you can see our test here failed. We had 1,175 records in our source tables, but only 1,170 records in our data warehouse. So that means for 5 records from the source system didn't make it into the target system. In addition, we had 353 records that had some type of data mismatch, where what we were expecting did not happen in the target system. And you'll see below you get some basic performance metrics as far as how long it took to run the queries, how long it took QuerySurge to do the analysis. So it took about 3 seconds to do this validation. But of course, what we really want to do is we want to know more detail. What actually failed here? So if we drill in to the query results, you'll see we have a tab for our source data. So this is the information that was calculated based off of our source query. We have a tab for the target data, which represents the data from our data warehouse. But what we're usually interested in is the failures. So what actually failed during this execution? So I'm going to use the side-by-side mode. And one of the things you'll see is for customer ID 4, they have a VIP level of 0, which means they didn't place any orders. But for some reason, in our data warehouse, the VIP level showed up as 1. So that's a bug that shouldn't have happened, because if we have 0 orders, and we can verify that, of course, if we go back to our orders table, we can look and we can look for any orders made by our customer 4, and you'll see it jumps from 3 to 5. So customer 4 didn't place any orders, which means they should have a VIP level of 0. But when we look at the target data warehouse, that VIP level is showing up as 1. So that's a problem. In addition, you'll see that many of these that are flagged with a VIP level as 3 are actually coming up with a VIP level as 4 in the system. So maybe there's something wrong with the ETL code that's not properly placing the VIP level based on a particular order count. And of course, we can go back into those specific orders and take a look at them. In addition, we noticed that there were some records that didn't make it into our target system. So if we kind of take a look at the non-matching rows, you'll see that we had 5 records in our source system, and there's no corresponding value in the data warehouse. So something happened in the ETL process where these 5 records didn't come over properly. So what I'd like to show now, to kind of wrap things up, is how to integrate all those different pieces that we talked about, the generation of the data, the ETL job, and the results that QuerySurge creates into our build pipeline. So what I'm going to do now is I'm going to jump into our Jenkins environment. And what I'll do just to prove that we're doing this live is I'm going to just quickly delete all of the data in our tables. So I just have a couple script here, which is going to delete them. And again, we'll just do a quick refresh to show you that those tables are clean. We'll do it on the data warehouse as well. And then we're going to execute a Jenkins build, which is going to execute these processes. So if I go and look at the Jenkins output, you'll see that it's generating the data just like we did from the command prompt before. And of course, I can validate that by quickly toggling in and looking at our orders table, doing a quick refresh. You'll see new data is generated. Now the ETL job is running, which is going to populate our data warehouse. And once that ETL job completes, the next phase is to go ahead and kick off the validation tests. So we're going to make the request to QuerySurge. And I'm going to log into, or I'm going to toggle over to the QuerySurge dashboard. And you'll see we queued up this new scenario that's going to run. You'll see when it changes to orange, that indicates that it's executing. And because it was a single query pair, it ran pretty quickly. And you'll see that it failed. And just like when we did the design time run, we can see the exact same information. We can see the source data, the target data, as well as the failures. And just like before, we have the same failures that we saw before, which is we have that VIP level 3 showing up as 4, and then we have where VIP level 0 showing up as 1, and we have the same number of missing records that didn't come over. And lastly, what you, of course, typically what you would do here is once you indicate that you did run into this problem, you would also get automatic email triggers that can be sent out that will contain the information as far as what passed, what failed, the different row counts that occurred, how many data failures happened. I won't do it here, but you can click on this link and it will open up a new tab, ask me to log in, and take me directly to QuerySurge right to those failures that we saw. So what I'd like to do one last time is just to show you, okay, let's say we take that data, we export it out to CSV or an Excel file, we give it to the development team, they apply a fix, and then we want to run the build again for the fix. So again, what I'll do is just clean out the data, and I don't have to do this. I think the job itself actually cleans the data out, but just to show you that we're cleaning all that information out. I'm going to go back to my Jenkins project.
Excuse me, Eric.
Sure, Bill.
We're kind of running out of time, so I was hoping to jump in now and start with questions.
Okay, sure. So I'll run this while the questions are coming in. So let's
Sounds
do
good.
that.
So just to let you know, we're not going to shut down in the next 7 minutes. We're going to continue with questions. So if you could stay on, that would be great. First question's for Eric. Pulling the source and target data, what format are those data sources being converted to for comparisons?
So when QuerySurge is querying those that information, it's pulling it directly from the source and target databases, pulling that data into the QuerySurge database, and then the analysis gets done on QuerySurge. So one of the benefits there is you're not putting any load on the systems that you're testing. We're just making a simple request to the data against those systems, bringing it into QuerySurge, and then doing the analysis after it's completed.
question's for Heisel. How about data subsetting when data in the non-prod environments need less data than in the prod environment?
Sure. So it's easy enough to specify in GenRocket the type of data you want to create, because GenRocket recognizes parent-child relationships. Once you specify your loop counts of the subset of data that you want to generate or the enumerations, yes, that's easy enough to do.
Okay, this is for both of you. It's a two-part question. Heisel, you get the first part. Can we generate lobs up to 2 gigs?
You can generate anything you want. And if you want to generate a blob up to 2 gigs, you absolutely can. And then that would use a particular receiver that would most likely write out to a blob.
Eric, can we validate lobs up to 2 gigs?
Yes, so QuerySurge can handle clob and blob formats. What it will do in the QuerySurge viewer is it will kind of display it as just as a clob field, but you'll have the ability to drill in there, and we have what we call a peek view, which will be able to display the first couple of characters just to get an idea if there's an initial mismatch. A lot of times clobs don't take up the complete size, but it will give you the mismatch, and then of course you could export that data and kind of determine why they mismatch.
Okay, for Heisel, our test users do not have authority to run inserts directly into a database table. How can we generate data to be loaded by someone else at a time separate from when the insert statements were generated?
Sure. So that comes more down to the policy of what you want. So GenRocket is not the determiner who has permission to generate data, except at the GenRocket editor level, where we have teams and different people have permissions to do different things. So you might want to create query statements that are just purely insert statements that don't populate directly into the database. So GenRocket doesn't care about the order in which it generates the data. It only cares that it generates the data. If you, for instance, put it into a scenario chain, it's going to produce that data in a particular order. Or you can run those scenarios at any time you want in any order, and they're still going to guarantee referential integrity.
All right, for Eric. After development fixes the issue, how do you run just a failed query pairs? How do you automate this?
So in QuerySurge, what you can do is you can create either a new suite based off of those values. So I'm just going to go into our section where we have the suites. So you can see this is a suite that has 3 different tests. So if you know that only a particular set of tests fail, you could create a new suite, just add those tests that you want, or you can take the existing suite and remove, let's say, the passing ones to just execute the ones that are needed. You can either do this manually, or we also have a full API, which means you could take the results of a previous run, capture the names or the IDs of the query pairs that failed, and auto-generate a new suite with just the failed test and kick them off when you need to. So it could either be done manually or through an automated process through our API.
For Heisel, does GenRocket offer any industry-specific examples, such as healthcare versus sales?
Yes, we actually do have some videos on very specific industry-specific test data scenarios. But GenRocket is generic. Go ahead.
I was just going to add, yeah, we have numerous case studies. There's a resource section on the GenRocket website, and those case studies by industry vertical are available for download for the public.
Good.
Eric, what is the industry standard for acceptable pass rate of QuerySurge data validation results?
So it obviously varies between organizations and verticals, but you know, most of our customers are looking for high 90 pass rates. Anything larger than that means there's a significant amount of data being bad data that's being introduced into the system. So you're going to want your data, your pass rates. And then we're not talking about the query pair test rates, because you could run 10 tests and 5 of them could have failures. But if those 10 tests are running hundreds of millions of tests validations, and you know, you run into 10 actual field failures, your pass rate from a data reliability standpoint is going to be 99.99%. So that's the number I'm referring to. What percentage of the data is accurate? You're going to want that in the high 90s, and that's pretty much the standard that's out there.
For Heisel, is it manual selection of relationships or will GenRocket traverse the data model and generate the relationship by itself?
So GenRocket has 9 separate ways of pulling in data, metadata about relationships. Most people use our GenRocket XTX, which looks directly at a database over JDBC. It can pull in up to 10,000 tables with each having 100 attributes in about 8 minutes and establish parent-child relationships. And then, of course, there are other ways like XML, JSON, and so forth. Yes, so it absolutely can.
For both of you, does both GenRocket and QuerySurge integrate with GitHub Actions?
That's a good question. GenRocket is a Java-based application, and we built it that way so that it could interface to anything. So it also has its own API too, so people can actually program the scenarios in real time. But to date, we haven't run into an issue where GenRocket hasn't been able to interface with some outside source.
And on the QuerySurge side, QuerySurge has its own version control that's built in. So anytime you make a change to a query, that previous version is still available. However, again, through the API, if you want to manage all your queries externally in something like GitHub, and then at execution time, make a request to pull those down and to inject them into query pairs, that can be done through the API.
For Heisel, can we use our custom generators and add it to the existing ones?
So GenRocket has a very strict policy on how we generate our generators, and that's why we have 258 different generators. We tend to add new generators, implement them, and add them to the platform in less than 3 days. So if there is a very specific type of generator that we currently don't have, we will implement it for free. But our generators do talk to each other, so they can work in combination. So most of the time, the type of generation you already need is already there.
For Eric, are there any average statistics on how quickly source and target comparisons occur, such as with large row counts, wide tables, and large data types?
Yeah, so QuerySurge has put together a performance benchmark document that we use, where we ramp up the number of users, the number of records, where we standardize a test set that we're testing and ramp it up to 1 million, 10 million, 100 million, billion rows to see the response times that we get. We're always looking to kind of improve performance and looking for ways to tweak that. But in a general sense, what we've seen, if you used our recommended specifications, you can test about 1 gig of data in under 15 minutes. So if you're dealing, of course, with normal ETL loads, that's usually fine. If you're trying to do a large migration project where you're talking, petabytes of data, usually there's strategies there where you're not going to test every single cell of every single record, but you're going to come up with strategies to do checksums and row counts and different things. And then if something fails, do in more depth testing on those items.
For Heisel, is there a limitation on number of domains, attributes, and scenarios? Is there a limit on the amount of data that can be generated?
There are no limits.
Awesome. For Eric, were the queries used to pull the source and target data for comparison manually written or auto-generated?
So anytime there's ETL transformation that needs to be occurred in QuerySurge, you're going to have to write the SQL that's needed to do that. If you're doing data migration projects or what we call pass-through mappings, where there's no transformation happening to the data, but you're just comparing a column from a source table to another column in the target table, we do have a query wizard which gives you the capability to do that graphically. But for the more complex items, such as one of the ones we did today, that you need to write the query within QuerySurge in order to do the validation.
GenRocket, please describe support for mainframe flat files.
Sure. So again, let's say if you're using vSAM, that's just a fixed file format, and that we use our fixed file receiver. If there are other receivers, let's say like you want to do EPSIDIC, you want to do conversion from ASCII to EPSIDIC, then we have a receiver that would do that conversion. So the beauty of receivers, and the reason why we can add new receivers anytime we want in less than 3 weeks, is that they take data and morph it into some usable format. So if we don't have a format that is available, we'll quickly implement it for free and add it to the platform.
For Eric, is there a limit to the number of concurrent source and target comparisons that can run if you have multiple tests running at the same time?
There is no limit. QuerySurge has a concept of an agent. The agents can all kick off suites in parallel. So they will be making requests to the source and target systems at the same time, capture that data, and then pass it back to the QuerySurge server for analysis. So there is no limit, except you obviously have to take into account the hardware that you're using. If you're doing large scale volumes of tests and you're running them all in parallel, it's going to stress the QuerySurge system. So as long as you have the proper hardware, you can run those tests in parallel.
2 more questions, both of them for Eric. Eric, is there a way to quarantine a test, a query pair and QuerySurge, but still be running if you did not want to see it in the reports?
So QuerySurge does have data retention policies, which allow you to determine what information is saved and what information is archived. So we do have that capability, and then of course you can remove records if you don't want those to show up in any type of aggregate reports that you create.
And one last question for Eric. Can you share the BAT files?
The BAT files for the demonstration.
I'm assuming that's what it is.
Yeah, I believe we could probably do something like that, or make something available post-webinar where we have some of the information that we used to set up this demonstration as an example.
All right, we're done with the questions. Liz, I'm turning it over to you.
Thanks. That wraps up our Q&A session. Thanks again for your time and participation today. We will be sending a follow-up email to you with the link to the recording and our contact information if you have any additional questions. Thanks again and have a great day.
Thanks, everyone.
Thanks, everybody. Great job, Eric.
Yeah, excellent job, Eric. Thank you, everybody.
Thanks, everybody.